All right, so what we're going to do is we're going to do this Galvani experiment. We have two dissimilar metals here. Do you want to hold this up, please? And you're going to be on camera in a minute. We have a camera down here. And we're going to look at this one here, that's copper. Remember that Galvani used copper. And we've got zinc over here. And most of the casings of batteries are made out of zinc. We're going to need some frog juice. Well, I don't have any frog juice, but I do have some regular vinegar here. Now, Ruben, what I ask you to do is connect these two alligator clips to the metal studs on the other side. So you need to turn it upside down. And connect one there. And one here. All right, now, you can place this down over here. And this is some regular household vinegar here from Reinhardt's. And I think those, they're in Stainer. I'd like you to pour up to about, I don't know, 400 millilitres, 500 millilitres in there if you don't mind. So this is our acid. This is acetic acid, or regular household white vinegar over here. And Galvani's frogs were pickled. You know, pickled in a vinegar to stop them from going mouldy. So we're going to use acid today. Now, I'm going to ask you to stand over here and place that. I'm going to ask you to hold this just like that, please. Now, this machine here is called a galvanometer. Named after Galvani. And what happens is that if it gets electricity, like you plug a battery into it, the needle will swing one way or the other, or both directions. So what we've got is we've got an acid here, we've got two metals, we're going to do electrochemistry, we're going to do a bit of chemistry. I'm going to ask Ruben to place this in here, just hold the top. And it says just vinegar. And is there anything happening here?
Yeah.
Right, do you want to take it out? And put it back in? What happens to the needle? What's the needle do?
It moves.
Does it move in two directions or one direction?
One direction.
It's a direct, it goes in one direction, so it's a direct current. That's DC. And what will happen here is Ruben just made the world's first battery. Two metals and an acid. Now, you're stuck somewhere, but to charge your cell phone, you know, this is how you make electricity. All right, first things first, let's give this gentleman a round of applause, please. He did very, very well. All right, so this is what was invented by Volta over here. Now, so here, just a quick illustration. Yeah, just leave it there. A quick illustration: zinc, copper, and then you can see that's the flow, you know, the current. As you can see, it's going and it's making energy in the form of light and heat, and light bulbs going off. All right, so there you have a quick look at what's happening over there. You can see those electrons sort of jumping from one atom to the next. We don't move the atoms, just the electrons from one atom to the next. All right, so let's take this a little bit further then. Let's talk about how batteries work. Well, we just made a battery over there, and you know, I don't know how many cell phones you've had in your life. Obviously, I'm older and I've had a few more cell phones, not a lot. But think how many batteries we use. Think of this Christmas, how many batteries are going to be used. And that stuff's got chemicals in there. Really got to think about better ways to recycle these things. Now, here we have Galvani doing this experiment here. Yeah, we're going through that. All right, so we're going to stimulate some muscles to see how Galvani's experiment worked. So to do this, I need a volunteer. In fact, I need a teacher as a volunteer here, because I'm going to stimulate a teacher's muscles, and you have to be voluntary on this one here.
Sandrine.
Madame Sandrine.
Because we're one class out of this entire school.
Okay, so what's your name? Lisa, Sadel. Now, I'm going to need to attach a couple of electrodes to your arm. So, you want time. And what we're going to do is we're going to do the experiment, do Galvani's experiment. And also, you can vote on that as you're going on here. So, first we're going to have the camera down. You can still vote. Now I have two electrodes here, which I'm going to apply to your arm. So one's going to go down here. Now I tried this on myself earlier on. So, just so you know. Now, what I'm going to do is ask you to place your arm like this, so it's relaxed and your fingers are nice and relaxed. Now, I'm going to turn on the device and I'm going to put a stimulation through your muscles here. Now, if it gets uncomfortable, just tell me and I'll turn off immediately. So, that was our first intense. Feeling anything? And can we see, look at the fingers there, and see if we can get your finger to pulse.
Oh.
See your fingers? Is that uncomfortable? Can I do one more? Okay. And that was voluntary. All right, I'm going to go back. Okay, like that. So relax your arms again. And once again, I'm going to hold this here, and you can see me coming up with the, and see what somebody just.
Whoa.
Okay, I'm going to turn it off there. Right, let's give this young lady a round of applause. That's really, really well. I have to charge you $20 for that, you know, because that was therapy.
Voodoo magic.
All right, well, let's go back to our screen. We got 39 votes on there. What do you think? I like you're calling it out. Yeah. Okay, how are we doing? 79. 85. Did you shout out 4? It's only the teacher. Do you know they do mark your papers? You don't know that. Yeah. All right, so that's what we got over here. 21%. Fifth year. All right. Yeah. It was a very. The voltage was high. It was very high voltage, but the current was very, 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 very small. So that's very good. All right. So. And then it gives you an idea. Flow of electrons through a conductor. We use coulombs per second or amperes there. And you can see a lot more electrons, obviously going to be a lot more amps going through there. It's just that's a visualization of what you might actually see if you had special super sight. All right, so let's talk about conductors and insulators because we've used this word here. A good example is the illustration up here. We're going to do an experiment. Need volunteers, though. We need to repoll this one, I think. Yeah? All right, so I need a volunteer for this one over here. I'm going to go for, well, I haven't been at that one over here yet. How about this young lady over here? Yeah. Well, except for as a teacher. I'll get back to you, don't worry, I'll get back to you. Yeah. Got stuff. All right. So, we're going to test conductivity. What's your name? Tiffany, I'm going to ask you to stand over here for a second. We've got a really cool thing for conductivity. All right. So, no expense spared here. Okay. So, we have this tube over here. So, here we've got a metal part, and this is a plastic part. So, Tiffany, I'm going to ask you to hold the plastic parts for a moment. Now, we're not using any high voltages here, so everything we use is going to be very safe. Now, if you touch the two together, just touch them like that. So they make a noise. Can you move backwards, forwards? Oh, it was working before. Hang on. That's not working. Hang on. Okay, do you want to touch the metal part? Move your hand up to the metal part. So you've got to touch that back there. This, watch the thing. I'll just do this, watch. You hold that bit there. Okay, oh, both of them. And that one here. Okay, so, and then take them apart. All right, and put them back together again. Right, so we can use this for conductivity to see if electricity passes through things. So you need to hold those. And we're going to test a few things. I'm going to bring them onto the stage here now. Firstly, let's go back to our screen, go back to our PowerPoint, see where we voted here. Let's get a vote here. One of these materials is an insulator. Now, I've got a bunch of materials. I've got some pasta here. I've got some graphite. This is the same stuff in your pencils over here. I've got some copper. Some copper over here. And I have a fibre optic cable over here. Now, just to give you an idea of fibre optic cable, let's have the lights down a little bit. If I just shine a laser through there, you can see that's a fibre optic cable over there. Okay, Well, yeah, exactly. Right, so lights back up again. Right, now, what was your vote? 61 people have voted. Come on, guys. Vote. Which one is this is the insulator? One of these is insulator. Which is the insulator?
Insulator?
And we did the teacher, so we know what the human skin's like, so we don't have to worry about Tiffany. We're not going to be zapping you. You're okay on this one over here. Okay. Oh, wow, we're up to 91. Wow. See, there's more people than I thought. All right, let's see where we go. Oh, that was a laser in there. All right, so survey says number 3 fiber optic cable is the insulator. So we need to test this out. First things first, metal. There's a metal. So touch on either side of the metal there. Insulator, the electricity goes through, that's not an insulator. Let's try this here, put them on here. Don't do that. Oh, we got screening, so that one allows electrons through, and most all metals, but graphite definitely. Graphite definitely. Let's see. Oh, pasta. Here, we've got some wet pasta. Do you want to hold that up there? Put it onto there. Yeah. That's electricity through. And last one is the fiber optic. No, it's always plastic. It doesn't, so that is definitely an insulator over there. Okay, let's give Tiffany a round of applause, please. Thanks so much. Okay. So, thank you. The majority there had that spot on. Nice job. All right, just to move this out of the way. So, the reason we have insulators is to, protect us from stray voltage. Like we saw the picture of the plug and socket. The orange cable is made of rubber. Rubber's an insulator. The soles of most people's shoes are rubber. They're insulators. Leather, apparently not. Okay, so, join the resistance. No, that just seems to, Anyway, go ahead and talk about resistance then. That's a good question, resistance. What is resistance? Resistance is that it slows down the flow of electricity, and we're going to do an experiment here. I'm going to electrify a pickle. And I have a pickle over here.
Pickle break.
And what we're going to do is we're going to see if this can be used as, in the future, if your light bulb fails, perhaps we can use a pickle. So first, I'm going to place a pickle on this torture device here. Now, let me explain what's going on. First, I had a choice of pickles, and I went with these rather than those because those were bigger. I have 2 retort stands, and I have 2 cables which are connected to this device here, which is called a variac. And what a variac does is I can increase the voltage on it and see if this will make a very good conductor, make a very good light bulb. Now I have 2 nails which go through wood. Wood is an insulator, so it's insulator. 2 nails which are conductors. Here is my cable going in. Here's my on switch. I've connected it to a power bar here. The power bar has a fuse in it, just in case anything goes wrong. So we're going to bring the lights down, and I'm going to power up the electric pickle.
The pickle's going to light up.
Okay,
So that was the
we
pickle
should be... there we go.
The pickle's lighting up!
I already knew
Wait,
about
no, it's burning.
No,
Rick
this
and
is
Morty
the
talking
science
about.
centre, not the Demon Magic Centre. That's down the street. Yeah.
Correct.
Well, that's going to be a great Christmas try, I must admit. Pickles.
I'm using this as my
that was
for my
pretty
Christmas
good.
tree.
So, is it a conductor and insulator? It's conductor. It's conducting electricity. All right. Let's turn that off there. We'll isolate that. Okay. Let's have our screen back up there. And ask a simple question here. You can see the variac was increasing voltage. The path was going through the pickle, which was the load, and we had the switch there, which I turned on and off. So, why does the pickle glow? Oh, I need to repol. Okay, is that repolling? No? A bit of trouble. Okay. There we go. Yeah, it's nice, isn't it?
They can smell it.
This is how Pickle Rick was born.
It is. You just eat it.
What happens if you eat that?
Okay, couple more. All right, let's go for 890. Come on, let's get to 90. Apparently not. Okay, so we go for that. All right, so yeah, it is electrical energy is converted to light and heat, and I don't know what smell is an energy, but it certainly did smell. All right, so let's talk about resistance here, and I need 2 volunteers to help with this resistance experiment. And I have to go to you over there, gentleman with the blue shirt there, because I promised you. Look down. But I do need somebody else you know who you're pointing to? You should come out. Who's that at the back there? Yeah, you come out. Come on, go down.